Alright, so we have a sub today. This is the 11-3 areas of polygons notes. So this is on page 326 of your student journal. So if you open that up. Again, you should do this at your own, or try to keep up. But if you need to, you can ask the sub to back it up so you can hear something that you missed. Also, I'll be sending you a link that you can listen to on the phone, or so that you can watch it on your phones. It's a YouTube link. Okay? So we did start this today. I'm going to start from today. So this is from Friday. But like I said, we did start this today. And but I'm going to just go over it so it's all completely fresh. Okay, so the first thing, we have a radius. And a radius is a radius is a segment from the center to a vertex or a corner. So this right here is a radius. So from here to here, that's a radius. And an apothem is, if I draw these two radii in, I make a triangle, and the height of the triangle, so this right here, that, and that, it has to be, this point has to be the midpoint of the side. That segment is the apothem. And then, let me grab another color. If I draw these two radii, I get an angle right here, and that angle is the central angle. And central angles can be found by taking 360 degrees and dividing by n. Okay, so to find the area of a rectangle, the formula is base times height. So the base of this is 5 and the height is 2, so 5 times 2 is 10, and this would be 10 centimeters squared. To find the perimeter, you just add up all the sides. So since this side is 5, this side is 5. Since this side is 2, this side is 2. So the perimeter would be 5 plus 5 plus 2 plus 2, which is 14 centimeters. Okay, the area of a square is base times height. Since all of these are 3, I get the area is 3 times 3, which is 9 inches squared, and the perimeter is 3 plus 3 plus 3 plus 3, which is 12 inches. Okay, number for this one, we're looking for the area of a parallelogram. So the area is just base times height. But this is the height, and you know it's a height because this is where the right angle is. So wherever the right angle is where the wherever the right angle is where the height is. So the base is 4 and the height is 2. So the area is 4 times 2, which is 8, and this would be meters squared. Now the perimeter, this would be 4. And this would be 3. The perimeter is 4 plus 4 plus 3 plus 3. So that's 8 and 6 is 14 meters. Okay, for the area of the triangle, it's base times height. Again, this is the height. So it's going to be 4 times 6 divided by 2. So 24 divided by 2, which is 12 centimeters squared. And I can't find the perimeter because I don't know these two sides. But if I did have those two sides, I'd just add them up to find the perimeter. Okay, and then we have a trapezoid. This is base 1, and this is base 2. And again, where the right angle is the height. So this is the height. So the formula is the height, which is 9, times base 1, which is 15, plus base 2, which is 27, divided by 2. Now, it doesn't matter which one you call base 1 and which one you call base 2. You'll get the same answer either way. So I'm going to add 15 and 27. And I get 42. So I get 9 times 42 plus 2. 9 times 42, not plus 2, divided by 2. Anyway, 9 times 42 is 378, and 378 divided by 2 is 189. So this would be 189 kilometers squared. Okay, so this one is the area of a rhombus or a kite, and it doesn't matter. The formula is the area is 1/2 the diameter 1 times diameter 2. So this is a rhombus because all 4 sides are equal, and this is a kite because disjoint sides are equal. These 2 sides are equal, and these 2 sides are equal. And the formula is all of diagonal 1, so this whole length here, so this whole length right here, times this whole length right here, divided by 2. And the same thing for the kite. This whole length right here, times this whole length right here, divided by 2. So we have some practice problems. I'm going to get a new color pen. So this distance right here is the 5, and this distance right here is 11. So for this one, I'm going to do 5 times 11 divided by 2. So I get 55 halves, and that would be feet squared. And if I wanted to, I could get the decimals for that. 55 divided by 2 is 27.5. So 27.5 feet squared. Now for this one, this whole length is 24, and this whole length is 10. So I'm going to do 24 times 10 divided by 2, and that's 240 divided by 2, which is 120 millimeters squared. Alright, so here's a practice problem for problem number 1. This is on page 327. Okay, so I'm going to ask that the sub pause it so you guys can try this one on your own, and then he'll pick it up. Okay, so this whole diagonal is 14, and this whole diagonal is 20. And remember, it's diagonal 1 times diagonal 2 divided by 2. So we're going to do 14 times 20 divided by 2. So this looks like 280 divided by 2, which is 140 inches squared. Okay, so number 2, I'm going to ask that the sub pause this so that you guys have a chance to try this on your own, and then we'll pick it back up. Okay, so this diagonal is 5 plus 3, which is 8. And this diagonal is 2 plus 2, which is 4. So the area, remember, is diagonal 1 times diagonal 2 divided by 2. So it would be 8 times 4 divided by 2. This would be 32 divided by 2, which is 16 centimeters squared. Alright, for number 3, we want to find the measure of the central angle of a regular polygon that has 8 sides. So remember, the central angle formula is 360 divided by n, where n equals the number of sides. So I'm looking for the central angle. So the central angle is equal to 360 divided by n, but n is 8. So when I do 360 divided by 8 on my calculator, I get 45. So I know my central angle is 45 degrees. Okay, so I want you to try number 4 on your own. So I'm going to ask that the sub pause it and you give it a shot. Okay, so that's enough. The central angle of a regular polygon, the central angles of a regular polygon are 40. How many sides does a polygon have? So we're going to have to work backwards. We still know the formula for a central angle. It is 360 divided by n. But this time I know what the measure of the central angle is. It's 40. So I'm going to replace the central angle here with 40. And that equals 360 divided by n. I'm going to put this over 1 and cross multiply. 40 times n is 40n. And 1 times 360 is 360. So divide by 40. And I get n is 9. So this is a 9-sided polygon. Okay, now this isn't in the book. We're just going to talk about this. How could I calculate the area? Okay, well, it turns out that I could break this up into a bunch of triangles, and I can find the area of all of these triangles, and then multiply by how many triangles there are. So there happen to be 6 triangles here. So if I find the area of one of the triangles, then I would multiply that by 6 and I could find the area. So that's one way of doing it. And that formula will always work, okay? But there's also another formula that I'm going to teach you too. But let's look at this. And this is only true for a hexagon. So this is a 6-sided figure. So it's a hexagon. It turns out that this central angle here is going to be 360 divided by 6, which is 60. So I know that this angle right here is going to be 60. Let me put that in another color. So this angle right here is going to be 60. Now, because these radii are equal, that makes these two angles also equal. Okay, and all 3 angles have to add up to 180, so these all 3 have to be 60. So this is an equilateral triangle. So that means that all of these are 8. So I'm just going to draw this triangle. And I know that this is 60, this is 8, this is 8, and this is 8. Sorry. But now I'm going to cut this triangle in half, which I had already done, so now I'm going to go ahead and put it in. So right here, if I cut it exactly in half, then this was a 60-degree angle. Well, now it's half of that, so that's 30. And this side right here is 4, because it's half of the whole way across, which is 8. So this right here is a 30, 60, 90 triangle. Okay, and I need to find the area of this triangle. I need the base, which I know it's 8. And I need this right here, which is the height, which is this right here. So I need to find that height. So I could either do the Pythagorean theorem, or if you remember your properties for a 30, 60, 90, I know that the hypotenuse is equal to the leg times, the hypotenuse is equal to 2 times the short leg, and the long leg is a short leg times radical 3. So this is 30, so this right here, 4, is a short leg, so the long leg is 4 root 3. So I know that this height right here is 4 radical 3. So the area of the triangle is the base times the height, which is 4 root 3, divided by 2. And 2 goes into 8 4 times, so I get 16 radical 3 for the area of one triangle. But there are 6 triangles, so I'm going to multiply that by 6. So 6 times 16 radical 3. And then I do 6 times 16. And I get 96 radical 3. And that's the exact answer. And then if I just plug that into the calculator, 96 times the square root of 3, I'm going to get 166.3. Okay. All right. So another formula, instead of finding all the triangles and adding them up, the formula is 1/2 the A, which is the apothem, times capital P, which is the perimeter. So that's a way that I could find the area of a regular polygon. So let's look at this hexagon. So I know that the diameter is 32. So that means that this has to be 16 because the radius is half of the diameter. Okay, and then if I were to draw this one in here, this would be 16. And this whole thing would be 16 also. But when I cut it in half, I get that this much is 8. So when I just look at this little half triangle here, I know that this is 8, and this is 16, and this is 60, and this is 30. And again, it's because this is a hexagon that this whole big angle was 60. And when I cut it in half, I got 30 here and then 60 down here. So I'm looking for the height. That's that right there. And that's the apothem, or the height. So I can do, this is a long leg. So the long leg is a short leg times radical 3. So this is going to be 8 radical 3. Okay, so my area is, I can find the area of the triangle if I wanted to. This right here is 8 radical 3. So I could do 8 radical 3, that's the height, times the base, which is 16, divided by 2. And I get, 2 goes into 16 8 times, so I get 64 radical 3. But then I would have to multiply that by 6, because there's 6 of these triangles in here. So 64 times 6 is 384. So I get 384 root 3. And we'll come back to the decimal in a second. The other way I could do it is use a apothem times the perimeter divided by 2. Well, I just found the apothem. It was 8 radical 3. The perimeter of this is, each of these sides is 16. So there's 16 times 6 for the perimeter, which is 96. So the perimeter is 96. So it's the apothem, which is 8 root 3, times the perimeter, which is 96, and I divide that by 2. So if I do 8 times 96 and then divide by 2, I get 384 root 3. which is what I got doing it the other way. So you'll see I get the same answer. Alright, so I'm just going to plug that in, 384 times the square root of 3 on my calculator, and I get 665.1. Alright, so we have, for number 6, we have a regular hexagon. So again, it's another hexagon, and it has an apothem of 10. We have to find the length of a side, and then the area of the hexagon. Alright, so I'm not going to draw the whole hexagon. I mean, here it looks something like that, right? Okay, but I know that this right here is 10. But really, well, all I care about is that little equilateral triangle down here. So I'm going to draw it. And I know that the apothem is 10. Now I'm going to split the triangle in half.
How long have you stayed here? Forever?
Okay, so I'm sorry. Miss Rucker didn't see that I was, or didn't know I was recording. But that was Miss Rucker. So we have to find the length of one of the sides. So we're really looking for this side right here. But again, I know this is a 30, 60, 90. Because this is, once again, it's a, it's a hexagon. So I know that this angle right here is 60. And when I cut it in half, I get 30. So that was 60, and when I cut it in half, I get that 30 right there. So this is a long leg. And the long leg is a short leg times radical 3. So my long leg is 10, and that equals a short leg, we'll call that x, times radical 3. So I'm going to divide both sides by radical 3. And I'm going to get an answer, 10 divided by radical 3. I get 5.8. So I know that this is 5.8. So that means that these are both 5.8 too. So the length of this whole side right here is 5.8 plus 5.8, which is 11.6. So the length of one side is 11.6. Now to find the area of the hexagon, remember it's the apothem times the perimeter divided by 2. So the apothem we knew was 10, they gave it to us. And then we need to multiply that by the perimeter, but I don't know what the perimeter is. Well, there's 6 sides, and each side is 11.6 long. So 6 times 11.6 is the perimeter, which is 69.6. And so that goes here, and then divided by 2. So 10 times 69.6 divided by 2, and I get 348. Okay, so it's 348. Okay, so this one's not in the book. And I think we're going to scrap it. I'm going to do these two when I get back. Oh no, this one's good. I'm sorry. Never mind. This is easy. We're not scrapping it. We're doing it. It's easy. So a regular nonagon has a side length of 18 and an apothem of 24.7. So remember my formula is that area is equal to the apothem times the perimeter divided by 2. Well, the apothem is 24.7. It just told us that. And the perimeter is, a nonagon has 9 sides, so 9 times how long each side is, which is 18. So 9 times 18 is 162. So my perimeter is 162. So my area is the apothem, which is 24.7, times the perimeter, which is 162, divided by 2. So on my calculator, I do 24.7 times 162, and divide that by 2. I get 2000.7. So my area is 2000.7. Alright, and then the last one, this is on page 328. A regular pentagon has a radius of 4 and a side length of 3. So if I were to draw a pentagon, so that looks like a house that's wide. So there's a pentagon. And we know it's got a side length of 3 and a radius of 4. So I have this triangle happening here. These are both 4, and this is 3. But if I cut this in half, then I get that each of these are 1.5. So when I look at this little tiny triangle here, the half of one of the triangles, this is 4, and this is 1.5. I'm looking for this. I can do the Pythagorean theorem to find the height. So remember, leg squared plus leg squared equals the hypotenuse squared. So the legs are x squared and 1.5 squared. And that equals a hypotenuse squared, which is 4 squared. So I get x squared plus 2.25. 1.5 squared is 2.25, and that equals 16. Then I could subtract 2.25. I get x squared equals 16 minus 2.25. And I get 13.75. And I can take the square root. And I get x is the square root of 13.75, 3.7. So now I know my apothem is 3.7. And then my area is the apothem times the perimeter divided by 2. So that's the apothem. To do this, though, I need the perimeter. So let me grab another color, and we'll find the perimeter. So the perimeter is, there are 5 sides, because it's a pentagon, and the side lengths are 3. So 5 times 3, which is 15. So my area is the apothem, which is 3.7, times the perimeter, which is 15, divided by 2. So on my calculator, I'm going to do 3.7 times 15 and divide by 2. And I get 27.75. And that is the area. Okay. So we'll talk a little bit more about this on Tuesday. All right. Good luck.